So what we're going to do is kind of do this little activity first, where this is going to lead us into all of the different strategies of integration. But when you kind of start thinking about it all as a whole, it can be confusing. Like if I tell you, hey, this is an inverse trig problem, you could probably do it. But figuring out when to do what is confusing. Not everything can you actually integrate. And I don't mean you, I mean anybody. Some things just cannot be integrated. Okay, they don't work out. Okay, so we're going to kind of keep that in mind. And I'm going to explain what that means here in a minute, if you're not quite sure. So out of these three, it is possible that they all can be integrated, that none of them can be, or any combination. But I am going to tell you that on all three of these, you need to let u equal natural log x. Okay, so then what would du equal? 1 over x dx. So in my problem, I should have an x where? In the denominator. So if you notice on this one, I see an x in the denominator. Here I see an x in the denominator. Natural log of x is in different places, but that's okay. Those are both good. You see how C doesn't even have an x in the denominator? This problem cannot be integrated. Not by you or me or anybody else, okay, with what we know. So I'm not going to work out these problems completely, but what I do kind of want to show you is, well, what's the difference between A and B? Well, see where the natural log of x is? It's in the denominator, so that's where u should go. It should go in the denominator. And then remember, the dx and the 1 over x gets replaced with du. What is that integral? What's the integral of 1 over u? Natural log of absolute value of u. Okay, what would this one be? Not 1 over u, just u, which we know we can integrate into half u squared. Okay, so I'm not finishing these problems. We're just kind of setting them up, basically. All right, well, let's look at the next one. Okay, on all these, I see a 1 minus x squared inside a square root. So there's a couple of different ways you could think about this. What does this make you think of? What type of problem do you think these are? It kind of looks like inverse trig. Which one? Arcsine or arctan? Arcsine. One of these is exactly arcsine. The first one, right? Okay, that is exactly the formula for arcsine of x. Not problem, but B and C are different because they have an x somewhere else. So B and C are not inverse trig. B and C are just normal u substitution. So try inverse trig if you think that works, but it doesn't work on every problem. So what should we let u equal to see if these problems work out?
1 minus x squared.
Yeah, 1 minus x squared. And then we got to continue on to know for sure if they're good problems or bad problems. Negative 2x dx. The negative 2 gets pulled out to the front of the integral as a negative 1/2. That's not a problem. I don't really need to look for that. But I notice here I have an x and a dx, and that's just a regular x. So where should that x be? On top. So B works. Okay, it ends up looking like this, negative 1/2, and I'm not going to write it as 1 over. I'm going to write it as u to the negative 1/2. Okay, that's a little bit messier than the ones we did before, but we could continue on with that problem. The problem with C is not so much that there's an extra x in the denominator. The problem is that we're missing an x in the numerator that should be there. C, we cannot solve this problem. We cannot integrate that. And before I go any further, let me just tell you, on the test, I'm not going to ask you, can you integrate this problem, yes or no, or which one of these can't be integrated. That's not why we're doing this. We're doing this to tighten up and totally look at this in a brand new way. Hopefully your understanding of these problems is a lot better by the end of this. Okay, well, let's look at the next row. I want, anybody tell me what you think we should let u equal in this row? X minus 1, okay? And I feel like we're safe to say this is not inverse trig, okay? So x minus 1. If u equals x minus 1, then what does du equal? Dx. So can we do problem A? Yeah, it would just be u to the 1/2 du. We can do that problem. That was kind of like one of the ones we did at the very beginning of u substitution. B and C are different, but that doesn't mean, and remember, they both could work or they both could not work. What do you do, though, in a problem when you have an extra x in your integral? Toko. This is a Toko problem. This is how you know it's a Toko problem. You have an extra x, and you got to say, okay, well, what does x equal? Well, if u equals x minus 1, just x is u plus 1. So the way we would rewrite this is we'd go ahead and write u to the 1/2, but we would multiply it by u plus 1, and we'd have to distribute, and it would be a lot of more steps to finish this problem. Okay, and I will work one of these out in a little bit. But right now, we're just saying, can the problem be solved? Yes.
Distribute the u to the 1/2.
Yeah, we would distribute, and then we would integrate from there. So what about C? Can we solve C? Is it a Toko, or is it unsolvable? What do you guys think? The thing is, you try it until you get stuck. So let's try it. Okay? I'm going to rewrite this. We already let u equal x minus 1. We said du equals dx, and we said x equals u plus 1. So this problem, what would the power on just u be, since it's square root and denominator? Negative 1/2. And there's an x right here. That's okay. I got an x over here. This is another Toko. It's not the exact same problem, but very similar. This one actually works as well. Okay, and again, we reassure you, you're not going to have problems on your test that can't be solved, and you're going to sit there and waste 10 minutes. Typically, when you can't solve a problem, what happened in the very beginning? You picked the wrong u. That's typically what happens when you can't solve a problem. Okay. So let's look at the next row. I think this is actually a little bit easier, because with E, we had some rules on what to let u equal. What was one of our main rules? Yeah. So we had some different things, but we said, hey, if there's a weird power on E, let's let u be that weird power. So in this case, u would equal x squared. So everything's looking good, but we got to finish with the du. We got to make sure our whole du statement is there. 2x dx. The number is no big deal. Numbers, you just move to the front. It's no big deal. What is the problem here, though?
We have an extra x.
We have an x. Do y'all see that? We have an x right here, but it's not in the problem. We cannot solve that problem. Everything in this du statement has to be there. I can deal with extra stuff, but I cannot deal with missing stuff. So what about B? It's the same problem, but with an x. This one I can do. Okay, it just ends up being 1/2 integral e to the u of du. Which, by the way, what's the antiderivative of e to the u? E to the u. That was the only function that worked out that way. Okay, so then what are you going to let the power be on C to see if that works out? What's the power on E? 1 over x. Let's rewrite that as x to the negative 1. So we're looking to see, is my du in the problem? So that's negative 1, x to the negative 2. The negative 1 I move over, it goes out to the front, no big deal. Is x to the negative 2 in my problem? Yes. X to the negative 2 is the same thing as 1 over x squared. So this one also becomes e to the u du. In fact, if the 1 over x squared had not been there, this would have been a problem I could not solve. So yes, I can solve that one. Okay. Last one before we actually practice some other integrating ones. What are you guys thinking on this? Look at the denominator. What does this make you think of? Okay, one of these is for sure arctan. Which one do you think it is? Anybody else? Well, you were so confident and everyone else was like, okay, so let's try it. That's the only way we're going to know for sure, right? So if we say, okay, what would the little a be? It would be 1, right? What would u equal in this case? X squared, because x to the 4th is supposed to be u squared, so u is x squared. Well, remember, to know for sure, you got to go all the way through your du statement. So du then is 2x dx. Again, the 2 is no big deal. It just becomes a 1/2. But look, I have an x here and I don't have an x there. This was a tricky one. This is tricky.
B is B.
It is B, so A is out and B works. Okay, that does end up being an arctan problem. Okay, it ends up being 1/2 arctan x squared over 1 plus c. Okay, what about c? It's not arctan, we already did that one. So what is something else that we did with problems like this? Something that we did earlier?
Well, you could split it up.
So I can split up the numerator, but I can't split up the denominator, although that was a good thought. I like that idea. Let's let u be the denominator. And if my du statement is in the numerator, then this is a problem I could do. So du is 4x cubed dx. Again, the 4 becomes a 1/4. That's easy to deal with. Is everything else in my du statement in the problem? Yes. So this becomes 1 over u du, which becomes a natural log problem, okay? So I can solve this one. Again, I'm not going to ask you, can you solve this? I'm only going to give you problems you can solve. But you got to make sure that you're not just throwing stuff on the paper hoping it works out. Things come out, things go in. It's not magic. It's science, really. Okay, so let's go over some of these strategies. We're going to talk about each main strategy, and then some of these we're going to actually integrate, and then some of them I'm just going to kind of talk about the strategy and we'll move on. All right, we're doing pretty good on time, so. Okay, so what do you think, doing all this u substitution, somebody might walk in here and say, I know how to do number 1, let u equal 2x minus x to the 5th. It's in parentheses. What's the problem with that?
Wrong.
Why? Because what would du equal? 2 minus 5x to the 4th, which is nowhere in your problem. This is actually not a u substitution. This is just take each piece and do antiderivative. Don't overcomplicate it. So leave a space, write your x, add 1 to the power, put the reciprocal in front. This is just what we did. Somebody else earlier today was like, the good old days. This is what we did long before we even knew there was a thing called u substitution. Okay, minus. Leave a space, add 1 to your power, write the reciprocal in front, don't forget your plus c.
So that's the answer.
That's your answer. Okay, so even 2, you might look at a problem like 2 and say, I tried letting u be the denominator, that didn't work. I tried letting u be the numerator, that didn't work. But what we can do, I mean, I have it here. By the way, there should be a dx there. That is a typo on my part. What we can do is, this is kind of what you guys were talking about earlier. I can split it up. And see how the denominator is just one thing? You can write each thing over that x. And now all I got to do is integrate each piece.
Can we not do division on that?
You could do division, and what you're going to get is, let me finish this out. So that would be x squared minus 4 plus 2 over x dx. If you did division, this is exactly what you'd get. You would get x squared minus 4 with a remainder of 2. So if you did long division on this problem, that's totally fine. If you're like, I got long division, that's easy to me, that may be something you actually really want to do. Although not necessary on this, you didn't have to. So then the antiderivative of x squared, I'm going to go through this part pretty quick, that would be 1/3 x cubed. Antiderivative of 4 would be 4x. Now this may throw you off, so what I'm going to do instead is just write the 2, and I'm going to change this 2 to a 1. What's the antiderivative of 1 over x? Natural log of x. We're used to seeing it as natural log of u, but it definitely works with natural log of x, or absolute value of x. Of course, plus c, right? Okay, let's talk now about, well, when do we do use substitution and why? Well, if you can't just use the basic rule or do something easy to rewrite it, you got to do use substitution. This is how most of your problems are going to be solved. So remember, the first thing that we did was, hey, let's use the parentheses. And so here you would let u equal x squared plus 1. Okay, I'm not going to finish that one out. I'm going to go ahead and move on to the second one. There's no parentheses here. And long division doesn't make sense on this problem because the denominator is actually bigger. So what are you looking for your u? What was something else that we did? And especially in these rational functions with a numerator and a denominator. What did we let u equal? The denominator. We let u be the denominator. So this is why we're going over this. There's a lot of strategies. I get that. That's why, this is why we're doing this. You just kind of have to have like, here are all my strategies. I try one, that doesn't work. I try something else, that doesn't work. All right, the reason this works out really well in this case is because du is 2x minus 1 dx. See how all that's right there? It works out perfectly. So this becomes 1 over u du. Okay, again, I'm not going to finish that one out. Because the setup really is the hardest part. Okay, what about the third one? We've already talked about this a little bit today. Right, let it be the power of e. So u is going to, and I'm going to write it as x to the 1/2. So then what would du equal?
1/2 x to the negative.
Perfect. And the 1/2 gets moved to the other side as a 2. I am going to finish this one, by the way. And here, let me just tell you, this was on the last quiz, by the way. This was one of your 4 quiz questions. And I saw a lot of this. Why is this not right? Even though, hey, I let u be square root of x, so there's supposed to be a u here. Why is this not right? It has to do with your du statement. Look, what is x to the negative 1/2? It is this. So you can't write it again. You're taking out square root of x in the denominator and dx, and when you put du right here, you got to take that out, the square root of x. Does that make sense? Okay, so then this would be 2e to the u plus c, which would be 2e to the square root of x plus c. Okay, So now we get to Toko. We've already talked about this a little bit, but we haven't actually solved any of these problems. So I am going to solve this one completely out. All right, so first off, how do we know it's a Toko? Oops, sorry.
First, like, you will be what's inside of
Yeah, we're going to let u be the thing inside the radical. So then du would be negative dx. The negative gets moved to the other side, just like any other number. And I notice here that because I let u be the thing inside the radical, I have u to the 1/2 right there. All right, but the reason this is Toko is because you have an extra x. A missing x is really bad news. You can't recover from that. But an extra x, that's a Toko. And you just got to figure out, okay, well, what does x equal? X, if I added it over to the other side and subtracted the u, would be 1 minus u. And that has to get multiplied to this u to the 1/2. And it makes it easier for you if you put it in this order. Like some people here may want to do this. Sorry, hold on. They may want to say, let this thing come first, and then this thing come second. Both of these are correct. The one over here on the left is better if you're going to continue in the problem, because now we have to distribute. So that's going to be u to the 1/2. And then what's u to the 1/2 times u to the 1? U to the 3/2. How'd you get that? You added those two powers, 1/2 plus 1. Okay, now I'm actually ready to integrate. And again, this is just using the basic rule of add 1 to the power, write the reciprocal. So I leave a space, I write the u, I add 1 to the power, 3/2, and I write the reciprocal in front. Minus. So on the next one, so what would the power be on the next piece? 5/2, so the reciprocal would be 2/5. And now you are almost done, but remember, you can't have u in your final answer. So I'm going to distribute through that negative. I think we should all be okay with that by now. If you didn't distribute the negative, that's okay. Remember though, on Toko, sometimes I'm nice and I give you problems where you really just have to go to this step. Sometimes that's as far as you need to go, especially if it's multiple choice or something. Huh? Oh, well, thank you. Sure. All right. Long division. So the question of the day is, how do you know when you're supposed to do long division? And there really is kind of something that is like a rule. So anybody think they know? So I can't split this up. Okay? I mean, I could split it up. That's not going to help me. All right? When the degree of the numerator is greater or actually equal to the degree of the denominator. Okay, see how this is an x squared over an x? That's a pretty good indicator that you're going to need to do long division. Now, I am going to do this problem pretty quickly. If you have no idea how to do long division, you will not get it in what I'm about to show you. Okay? If you have no idea how to do this, then you need to get into tutoring, get with a friend who knows how to do it and have them explain it to you, or go on YouTube and just search polynomial long division. There's a lot of teachers who put their videos on YouTube, and maybe one of them, the way they explain it is like a lot easier. Okay, so like I said, I'm just kind of going through the steps, but I'm not really teaching this because I've already done that a few times. Okay, we end up getting a remainder of 2. So what that does in this problem is it allows us to have like a mixed number, like a mixed integral, x plus 3, and then our remainder was 2, so I put that over x plus 1.
I have just like a question.
Sure.
If you got -2 as
You would go minus,
okay.
or you could go plus negative. That would be okay. Either way. All right, really what we want to do here even is this. You don't have to, but I think this makes the problem even easier if you just really go through and you say, I'm going to write this as 3 totally different integrals. Not just an integral with 3 pieces, but 3 different integrals. If that doesn't help you, then you may not want to do it. Okay? All right, antiderivative of x, 1/2 x squared. Antiderivative of 3, 3x. This you're going to need to do u substitution with. I'm going to skip how to do that, but you get natural log of absolute value of x plus 1 plus c. Because you would have let u be the denominator there. But I want to move on to the next part. All right. Basic trig. Okay, do you know your 6 trig derivatives?
Yes.
If not, you need to get your green flashcards out and get going on that. All right, which of the 6 trig functions derivative is cosecant squared x? Cotangent. And technically the derivative of cotangent is negative cosecant squared x, so I need to put a negative cotangent x. Still a plus c. When you know your 6 trig derivatives, these problems are really easy. Now, were there any where the derivative was tangent x?
No.
No. So what we need to do here is we need to rewrite this. Just using the basic identity of what tangent is. And then from here we need to do u substitution. I'm going to let u be the denominator. Hope that du is in the numerator. It is. It's all right there. So this becomes negative 1 over u du, which is negative natural log of u plus c, which is really negative natural log of cosine. Now, this is something that some teachers, and even I in the past, have made my students memorize, that the integral of tan x is negative natural log of cosine x. I have found that the less I make you memorize, the more likely you are to actually memorize it. So you don't have to memorize this one. You could always do it this way. All right, but then you have to think to do it this way. If you are good at memorizing, that may be, you may want to make up your own flashcard and do it, and do that one. Okay, let's look at inverse trig. So besides me just saying, hey, this is an inverse trig, how do you know that this is inverse trig? What's your clues?
There's a square root in the denominator.
There's a square root, and it's a number squared minus a function squared. Okay, the 5, don't let that throw you. We're just going to move that to the front. Okay, so we've got an a, we've got a u, and we've got a du, and if this doesn't work, I'm going to find out really fast if it's supposed to be some other kind of substitution. But it's not. This is going to work out. So what's a? 4. This is square root of 16. What's u? 3x. So du would be 3 dx. So remember, the 5 got moved to the front. The 1/3 now got moved to the front. This integral becomes the square root of a squared minus u squared, which is arc sine of u over a, or 3x over 4. Do you remember one of them? I mean, I don't know why I said it that way. Arctan has a little extra something in front of it. Do you remember what that is? 1 over a. Good. Okay, last problem. Separate the numerator, I think, is the hardest one to figure out because it's not really long division. It's not just splitting it up. The way you know how to separate the numerator is when you look at that denominator, and if you're like, well, one way, if this -1 wasn't here, I would do it one way. And then if the x wasn't here, I would do it a totally different way. That's how you know we'll split it up and then just work 2 problems, and there should be a dx there. So what we do is we go integral of x over x squared plus 25 dx. We go minus 1 over x squared plus 25 dx. I don't know how far I'm going to get through with this problem. Okay, One of these is inverse trig. Which one? The second one. That means this one's regular u substitution. So if you let u equal x squared plus 25, du then would be 2x dx. So you'd have, this is how I suggest you do it. That go through the whole piece. This is 1 over u du. So that'd be 1/2 natural log of u, or 1/2 natural log of x squared plus 25. So I suggest you go through and integrate the whole first thing. Then you come over here and you do the same thing. Now you guys already told me this is a arctan. A here is 5, u is x, du is dx. So remember, this is going to be 1 over a arctan u over a, and then we'll have our plus c. And there's a minus, so I got to make sure I put my minus there. 1 over 5 arctan x over 5 plus c. This